Hi everybody. Today we are going to discuss about Bohr's model of atom. Bohr's model of atom. After proposing the so many atomic models like Thomson atomic model, that is nothing but watermelon model, and Rutherford's atomic model, there are so many drawbacks in them. So those are not explaining about somewhat of electromagnetic radiation and spectral lines even for simplest atom like hydrogen. So these things were not explained in those previous atomic models. So to overcome those drawbacks, Bohr's proposed a model of atom. So this is nothing but Bohr's atomic model or Bohr's model of atom. His theory, so Niels Bohr theory is fully based on the principle of Max Planck about the absorption and emission of the radiation by an electron. So Bohr's atomic model is depend upon the principles of Max Planck. So Max Planck quantum theory. So Max Planck quantum equation. So E is equal to h nu. So E is directly proportional to nu. So here E is energy, nu is frequency. So if the frequency increases, energy increases. If the energy decreases, frequency decreases. So to remove that proportion, we have to add constant there. That is nothing but h. So that is equal to E is equal to h nu. So based on this E is equal to h nu, Max Planck theory, he proposed the Bohr's model of atom. So if you observe here, in order to overcome drawbacks of Rutherford model of atom, in 1913 Bohr proposed a new model of atom based on the modern quantum theory of energy. So quantum theory of energy is nothing but Planck's quantum theory. So with his theoretical model, he was able to explain as to why an orbiting electron did not collapse into the nucleus and how the atomic spectra were caused by the radiation emitting when the electrons moved from one orbit to other. When a charged particle revolving around the another charged particle, it continuously lost its energy and one day fell into the inside the nucleus. The atom will be destroyed, but still the atoms are stable. Why this is occurring is not explained by Rutherford atomic model. So this drawback is overcome in the Bohr's atomic model. So if you observe the Bohr's postulates, Bohr's postulates nothing but important points in Bohr theory. So what are the points were discussed in the Bohr's theory? Bohr's model of atom. So in his model, the postulates are like this. If you observe the first point, electrons revolve around the nucleus in specific circular paths. So we know about that. So electrons are always revolving around the nucleus in a fixed paths, in a specific circular paths. These paths are called orbits. The electron which is revolving around the nucleus, the path is called orbit. The another name of that orbit is shell. So shell or orbit both are same. These orbits are numbered as 1, 2, 3, 4, etc. or as K, L, M, N and so on respectively, and are represented by the symbol N. So the shell are represented with the symbol N. So if the N is equal to 1, that is the first shell. So first shell means which is closely to the nucleus. So if N is equal to the shell which is after first shell from the nucleus. So that's why in the way the numbers were given to the each shell. In other words, we can say that the shell names as K, L, M, N like that. KLMN like that. So if n is equal to 1, that is called K. If n is equal to, that is L like that. So in this way, Bohr give the names to the fixed paths. So those are called orbits or shells. Those are represented symbol N. Those are named as 1, 2, 3, 4 or KLMN like that. If you observe the second point is like this: orbit. Each orbit is associated with a definite amount of energy. So the the electrons are revolving around the nucleus in fixed orbits. So these orbits, each orbit is associated with a definite amount of energy. So each orbit has some amount of energy. Hence these orbits are called energy levels. So energy level. So, and if you observe the third point, as long as the electron revolves in a particular orbit, the electron neither gains nor loses energy. So the electrons revolving around the nucleus in a fixed path, there is no gains in energy, loss in energy. So an electrons revolving in a fixed path for even for long time, there is no loss in energy, no gain in energy. Therefore these orbitals are called stationary orbits. Stationary orbit means there is no loss or gain in energy, and the electrons are said to be in stationary energy states. So hence these orbits, these shells are called as stationary orbits or main energy states. So up to now we give the name to the shells like shells or orbits or energy levels or stationary orbits or main energy states. So these are the other names for shells or paths. And if you observe the fourth point, the energy associated with the energy levels increase with the increase in n value. So if you observe the fixed paths for electrons, so if the n value increases, so if n is equal to 1, n is equal to n is equal to 3, n is equal to first shell, n is equal to second shell, n is equal to third shell. So if the number n value shell number increases, the energy value will be increased. So if you observe, the first shell is having less energy compared with second shell. So when the n value increases, energy value will be increased. So if you observe the K shell's energy compared with L shell, L shell is having highest energy compared with K shell, like that. So M is equal to M shell's energy is greater than the L shell and K shell. N shell energy value is greater than K shell, L shell and M shell. So in this way, N value increases, the energy will be increased. And if you observe the fifth point, when an electron absorbs energy, it jumps from lower energy level to higher energy level and it emits. Similarly, when electron loses energy, it jumps from higher energy level to lower energy level. This absorption and emission takes place in the form of electromagnetic radiation. So highest energy level, lowest energy level. So lowest energy level means which energy level is having least value, that is called lowest energy level. So that means first level is lowest energy level. Highest energy level means above energy levels. So if the electron jumped from lowest energy to highest energy, when it is happen, if the electron absorbs energy, when the electron absorbs energy and it gets high energetic state, then it is go to higher energy state. So that higher energy state is not stable, so again it falls into the ground's lower energy states. So when the electron coming from higher energy state to lower energy state, it again loses in energy. So if you observe, when the electron is present in the lower energy state, whenever it absorbs the energy, it gets ignited, it gets energetic, and it jumps into the higher energy states. After reaching the higher energy state, again it lost its energy which it get previously, and again come back to ground states, lower energy states. Whenever it coming from higher energy to lower energy state, it again it's lost its energy. So when the electron absorb the energy, it jumps into higher energy state, when the electron lost its energy, I mean when the electron coming upside to downside, high energy to lower energy states, it again loses its energy. So by this phenomena, the energy absorption and releasing, this by this way light is emitting. So this is called electromagnetic radiation. So if you observe the fifth point, last one, this absorption and emission takes place in the form of electromagnetic radiation. Electromagnetic radiation is nothing but light. When the electron jumps from higher energy to lower energy, it loses energy. The losing energy emitted in the form of light, that is nothing but electromagnetic radiation. So if you observe, let E1 be the energy of the lower energy orbit. So for E1 is nothing but first energy levels energy, be the energy level of the lower energy orbit, and E2, so it is somewhat of higher energy states, like suppose if let it be 2 second energy shell, be the energy of the higher energy of the orbit. So E1 is the lowest energy of the orbit, E2 is the highest energy of the orbit. Then E2 minus E1, that means higher energy state to lower energy state, that is equal to delta E, that is equal to h nu. So h nu, so from if the electron coming from E2 to E1, it loses its energy. So the lost energy is emit in the form of light. So what of energy is equal to, that energy is nothing but light. Here delta E is equal to h nu. So where h is equal to Planck's constant and nu is equal to frequency of radiation. So E is directly proportional to nu. So whenever remove the proportional, when we have to add constant, that is equal to h. So here the h is equal to Planck's constant. So the h value is like this, 6.6256 into 10 to the power of minus 34 joules second, or if you say it in x, 6.6256 into 10 to the power of minus 27 erg second. So and delta E is the energy differences between the two orbits. So any two orbits are there, higher energy second shell to first shell, third shell to first shell, third shell to second shell, fourth shell to first shell, fourth shell to second shell, these are the any of them. So this is the energy difference of any two orbits. Okay, if you observe the sixth point, the angular momentum of an electron revolving in a particular orbit is quantized and is an integral multiple of h by 2 pi. This is known as quantization of angular momentum. So we know about angular momentum, MVR. So angular momentum, circular, in a circular way we are calculating the angular momentum. Angular momentum MV is quantized. So angular momentum is quantized, that means it is attached with somewhat of energy, that is equal to h by 2 pi. So it is integral multiple of h by 2 pi, that means MVR is equal to nh by 2 pi. So if you observe the seventh point, the angular momentum is given by the formula MVR is equal to n h by 2 pi. So why we are adding n here? N is nothing but shell number. So if the first shell, the angular momentum is different. If the second shell, the angular momentum is somewhat of difference, like that. So here n is equal to shell number. So in each shell, the angular momentum value will be different. So which is called Bohr's quantum condition. This is the quantum condition. This is Bohr's quantum condition. So each shell is quantized because each shell is energetic level. Each shell is having somewhat of energy. So each orbit, each shell is quantized. So angular momentum is quantized. Each shell's angular momentum is quantized. So this is the Bohr's quantum condition. So if you observe, where n is the integral, where n is an integer, like n is equal to 1, 2, 3, and this is also called as principal quantum number. We are representing the shells with the number with the symbol n. Those are nothing but 1, 2, 3, 4, 5. So this n is also known as principal quantum number. So energy levels are quantized, and m is equal to mass of the electron, v is equal to velocity of the electron, r is equal to distance of the electron from the nucleus, and h is equal to Planck's constant. So mvr is equal to nh by 2 pi. So once again let us discuss briefly about all the points. So if you observe the previous atomic models, there are so many drawbacks. They are not explaining about why the atom is stable, and how the electrons are revolving around the nucleus, and why the atom is stable, and spectral lines. This all the information is not given by the previous atomic models. To overcome those drawbacks, Bohr's atomic model theory is fully based on the Max Planck's quantum theory. So energy quantized. Hence we are saying that energy levels is equal to h nu, mvr is equal to nh by 2 pi. And in his postulates, electrons are revolving around the nucleus in a specific path. So those paths are nothing but orbits or shells. Those are named as 1, 2, 3, 4, 5 and so on, or KLM and OP and so on. So those are with the represent the symbol n. So n is nothing but also principal quantum number. And if you observe the second point, each orbit, each shell is associated with the somewhat of energy. Hence these are called energy levels. And since the electrons revolving in fixed paths, they are not gaining energy or losing energy. Their energy is constant, and hence these energy levels, these shells are called stationary orbits or energy states. And the energy associated with the energy levels increase with the n value. So if the n value increases, energy value will be increased. Energy shells energy will be increased. And electrons, when an electron gains the energy, it jumps into higher energy state. When electron comes from higher energy state to lower energy state, it continuously loses its energy. Then based on this phenomena, electromagnetic radiation is emitted. So electromagnetic radiation is emitted. That electromagnetic radiation is equal to h nu. So delta E, that means E2 minus C1 is equal to delta E, that is equal to h nu. So here the h is equal to Planck constant, here h is equal to Planck's constant, and nu is equal to frequency of the radiation. And delta is equal to difference in energy levels or energy states. And so each angular momentum, so each shell's angular momentum is quantized with some bind with somewhat of energy, that is equal to h by 2 pi. So angular momentum, each shell's angular momentum mvr is equal to nh by 2 pi. Here n is equal to principal quantum number, that is nothing but shell number. So this is the brief information about Bohr's postulates and Bohr's model of atom. If you have any doubts in this topic, you can comment below. Feel free to ask any questions in this topic. Thank you. Thanks for watching.